This is chapter 2 and quadratics. Now the problem we have here with quadratics is really knowing where to start, because of course you've done a lot of quadratics on the GCSE syllabus, so you'll find a lot of this chapter is familiar. Now what's important here is that you take something that was quite difficult on GCSE, quadratics, completing the square, using the formula, drawing the graphs, dealing with quadratic inequalities, and you need to make that something that's super easy. Okay, you need to get to the point where it's you can do it so easily that you don't have to think about it, because the quadratics, by the time you get to the A-level exam at the end of the second year of your A-levels, they're going to have to be really straightforward, because they turn up towards the end of a question or just halfway through a question in all the stats, all the mechanics things. Finding a quadratic partway through your question that just needs solving so that you can carry on is a completely familiar experience. Also in this chapter we hit completing the square, which is the first sort of stumbling block which A-level students get to. That seems to be the first thing that really kind of causes problems. So where we're going to start? Well, the first example in the book is this one, and I'm not going to go into the details here of how to factorize. When you're factorizing a quadratic and the coefficient of x squared is 1. If there's nothing written in front of the x squared, then we can factorize it x minus 5, there we go. So these two numbers times together to make minus 15 and add together to make minus 2x. I'm not going to go into any more detail there. What I will point out though is that that stage is just rearranging the left hand side of the equation. The next stage is actually the clever one. This is where we say two things times together equals 0. If two things are times together and the answer is 0, one of those things must be a 0. Okay, so we do all the work to factorize it, but actually mathematically the clever thing that we do is that we're trying to write this as a product. We're trying to write things as two things times together so that we can say, well, either this one is 0 or this one is 0, and then the answer is straightforward. Okay, so the idea of factorizing is to have it as two things times together to equal a 0. That obviously then doesn't work if this isn't a 0. If this is not a 0, if it's a 6, well, there's lots of things you can times together to make 6. You can do 1 and 6, 2 and 3, 12 and a half. You know, there's lots of different options. But if you've got a 0 as your answer to a multiplication, that tells you something. Now that's the reason that we're doing that is because if you try and solve a quadratic by your balance method, okay, so x plus 2 equals 6, take away 2 off this side, we get x, take away 2 off this side, we get 4. That's how we solve equations before we make quadratics. If we've got a quadratic of this form, x squared minus 2x minus 15, you can take away, you can add 15, you can add 2x, you can try and square root it, you can do all sorts of things, but you won't get an answer just from the straightforward balance method. Okay? Now, in example 2, they're giving us equations which are in, so this is example 2, page 20, we're giving us equations like this which are in completed square form already. Okay, we've got something in brackets squared and a constant. So if I get a quadratic equation like this, we can use the balance method now. So if I square root both sides, 2x minus 3 equals plus or minus 5. Excuse me. Let's hope I remember to edit that out. You'll see if I have or not. Right, so square root both sides to get plus or minus 5. We get 2x, and if I add the 3 on both sides, I get plus or minus 5 plus 3, and then divide by 2, I get plus or minus 5 plus 3 over 2. So my two answers are 5 plus 3 over 2, which is 4, and minus 5 plus 3 over 2, which is minus 1. So we have to use the factorizing method, or we can try the factorizing method if we can't just use the balance method. If we're in completed square form, we can use the balance method. Now that's worth remembering, because a lot of students have seen on exam papers or past papers, part A of the question will be complete the square, and part B of the question will be now solve the quadratic, and what they'll do is they'll uncomplete the square, they'll rewrite it in this form, and then use the formula, and actually you're doing a lot of work twice there that you didn't need to do. So the last thing from section 2.1 that we are going to deal with is example 1c, page 19, is the example of this in the book. and there's plenty more examples in the exercise. And it's when the coefficient of x squared is not a 1. The coefficient of x squared here is a 6. And that's difficult because if I try and put a set of double brackets down, I can't just have an x in the first bracket and an x in the second bracket. The x terms need to get times together to make 6x squared. So that creates a problem for us. There's different methods of doing this. You might want to look up other methods as well. My method that I prefer goes like this. I'm going to take the number at the front and the number at the end, so that the coefficient of x squared and the constant term, or the a and the c, if you like, times those together, and minus 30 is what we get. 6 times minus 5 is minus 30. Now what I'm looking for now is two numbers that times together to make minus 30 and add together to make 13. Okay, so I'm thinking about 15 and 2 as the factors of 30. 15 and 2 seem to be the pair that are going to work, and it needs to make a positive 13, so a plus 15 and a minus 2 is going to help. So I like to just, over on the right hand side somewhere, just write this down, and that's sort of rough notes. Okay, so here what I'm now going to do, 6x squared, now the 13x I'm going to split up using these two numbers, so I'm going to write it as 15x minus 2x. Okay, and now, so if you like, stage 1 is find the magic number and find these two numbers that times together to make the magic number and add together to make 13. Stage 2 is just split up the 13x into these two terms, and then I'm going to think of the first two terms and the second two terms separately. So in this case, 6x squared and 15x, well, I can take an x out of both of those terms, and I can take a 3 out of both of those terms. So 3x, and that leaves me with 2x here, and 5 here. And then these two terms I can factorize in a way that will leave the same bracket. Okay, so if I look at these two terms here, I can take a minus 1 out of both terms, and I get 2x plus 5 left. Okay, so magic number, two numbers that times together to make it and add together to make the coefficient of x. Stage 2, split up the 13x, the x term, into two separate x terms. Then look at the first two terms, look at the second two terms, factorize the first two terms, factorize the second two terms, and it will always be possible to factorize the minus sign out somehow, so that we get this bracket here and this bracket here are the same thing. Okay, 2x plus 5 here and a 2x plus 5 here. Now this is the bit that sometimes confuses people, and just think about it like this. If you had 3x times y minus y, well, what you could do there would be factorize the y out, wouldn't it? And have y times 3x minus 1. And that's exactly what we're going to do, but it's not a y, it's a 2x minus 5. So I'm taking this and bringing that out the front of the bracket. So I'm writing this as 2x plus 5, 3x minus 1. And there's my factorized form. And from there, it should be easy enough to say the first bracket equals 0 or the second bracket equals 0. And I can write that as minus 5 over 2, and I can write the answer here as 1/3. And there we go. That is an example where we've got a coefficient of x squared which is not a 1. Other than that, the only thing on this section is things like example 1D and things that turn up in the exercise on question 3. And the problem here is that they haven't started off in the nice form, or in question 2 as well. So they've given us a quadratic that doesn't look like a quadratic to begin with. We need to put everything over the left hand side and put it equal to 0. In those questions though, watch out for things like 3b and 3c, that here it looks like they're being mean and they haven't given us it in a nice form, but they've actually done what they've done in example 2. They've actually done completed square form, so it's even easier than solving a quadratic. We can just square root both sides, add a 3, divide by 2. We can use the balance method to solve these ones when they're in completed square form. So if it's not in the nice straightforward ax squared plus bx plus c equals 0 form, you want to put it in that form, unless you're in completed square form, in which case you're halfway there already. That is everything in section 2.1.